We present Thunderstruck, an interactive simulator based on our principled approach for the simulation of thunderstorms, enabling the experience of these natural spectacles in virtual environments. The elements of lightning and thunder are ubiquitous in culture and art, such as in classical music. Our approach is able to capture the variance of the propagation distance depending on different charge densities. The dielectric breakdown discharges can result in characteristic highly branched Lichtenberg figures. Their three-dimensional structures are also known as electrical trees. The pattern's fractal nature becomes apparent when zooming in. Dynamic objects are handled as well. Here, two facing electrodes with opposing charges create a lightning arch. If the distance increases too far, the arch ceases. Here we simulate the popular plasma ball experiment. When the glass is touched, primary and secondary discharges appear inside the gas. This scene contains complex discontinuous obstacles within the volume. Lightnings are guided by a potential gradient. Our approach finds the global minimum faster than previous methods. This also works in more complicated scenes. Lightnings can be classified based on their initiation and termination points. Here, we show the three main types: cloud-to-air, cloud-to-cloud, and cloud-to-ground lightning. Cloud-to-air lightnings are usually found in huge cumulonimbus clouds. These high precipitation clouds generate differences in electric potential, proving the basis for lightning. We have removed parts of the clouds to focus the observer on the visualization of the lightning. Although our simulation normally operates on a much larger temporal scale, adjustments can be made to simulate the temporal development of a single strike. The return stroke at the end is clearly visible. Apart from scientific studies and visual applications, the simulation of thunderstorms is also important in civil engineering. Lightning conductors can prevent damage on buildings by attracting and safely rerouting the charge. After the conductor is added to the scene, the center remains almost free from strikes. We can initialize the simulator with real-time weather data to enable nowcasting of complex thunderstorms. On April 25, 2022, a big cold front extended from Texas to the north of Mexico. Now, we experienced the thunderstorm over Cerro de la Silla in Monterrey on that day. The sudden air expansion of the lightning also creates a thunder. Various atmospheric conditions such as temperature, humidity, and pressure have an impact on how the thunder propagates through the atmosphere to the observer's location. By extracting these parameters from our simulation, we can adjust a reference thunder sample to generate the various sounds of a whole thunderstorm. Apart from frequency adjustments, other effects are simulated as well. Most well known is the delay between lightning and thunder caused by the speed of sound being much slower than the speed of light. The delay depends on the distance of the lightning, which also causes an attenuation. Since cloud-to-cloud lightnings are typically further away, frequency adjustment, attenuation, and delay are more pronounced. Panning based on the direction of the lightning creates a surround effect and makes it easier to distinguish overlapping thunders. Thank you for your interest in our work and watching this video.